Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's very hard puzzle for the day. I'll put a disclaimer out there. I actually did try this earlier, but the problem was that I didn't understand the rules well enough to be able to continue solving the puzzle. So I just stopped basically in the middle of it. I wasn't very far along, so I don't know that much of the logic. But yeah, that's just the caveat. And it's called but this is a very hard, supposedly, puzzle, and it's called The Equalizer by Playmaker 6174. And let's get to the rules. And I'll have some clarifications here. Because I did get some clarifications from the setter himself. Because I was like, hey, I don't understand this rule. What does this mean? And he clarified for me, which was great. Thank you, Playmaker. Here are the rules. Normal Sudoku rules apply within the 9 by 9 grid. So inside of these lines, you must place the digits 1 through 9 in every row, every column, and every box. That's within the 9 by 9 grid. Remember. For all lines that belong to the same color, in this case red or gray, it says the rule says all digits along these lines must have the same sum, which needs to be deduced for each color. It's a little confusing about the way that's put. It's also not all digits. It's actually all numbers along each of these lines must add up to the same sum. That's the way I would put it, which needs to be deduced. Different colored lines may or may not share the same sum. So for all lines that belong to the same color, the sum of all the numbers along each of these lines must have the same sum. The sum of all the numbers on the line must be the same. That's the way I would put it, and that's what I was clarified for, because I didn't understand whether it was digits or whether it was actual values, numbers itself. And the author clarified that it was actual numbers. So, for example, if this was a value of, say, 12 or something, and this was a value of, like, I don't know, 15, and then this was a value of 7, then these three added up would be 7 plus 12 plus 15, which would be 39, I think, in that case. 27, no, 34. It would be 34. So then all the gray cells would have to equal 34 if this is valid, if this is the case. And it would not be 1 plus 2 plus 1 plus 5 plus 7, which sort of implied when he says digits along these lines. And that was the clarification that I needed personally to be able to really solve this problem. So basically, yeah, you take the sum. So for all lines that belong to the same color, which is red or gray, all numbers along each of these lines must sum to the same number. So so the way I would put it, I think, is for all lines that belong to the same color, the sum of all the numbers on each line must sum to the same value. That's the way I would put it, which needs to be deduced for each color. And different colored lines may or may not share the same sum. An outside cell that contains a line segment is an X sum clue, which shows the sum of the first X digits from the clue's direction in that row/column, where X is the first digit placed from that direction. Note that numbers along a line can repeat if allowed by other rules, including both inside and outside the 9 by 9 grid. So that just means that digits can be repeat along the line if the other rules allow. X sum is, so for example, if this were like a 24 and this was 5, that would mean that the first 5 digits, including the 5 itself, would have to add up to 24. Same thing, for example, if this was, say this was, I don't know, 32 or something. 34. Let's make it 34. And this was 7. If this was 7, that means the first 7 digits would have to add up to 34. And that's xsum. The table at the top right is for entering the totals of each line. So these are just basically cosmetic. Don't really need to worry about it that much. And it's just normal Sudoku otherwise. Anyways, if you'd like to play along, there's going to be a link in the description. And now, hopefully, with the actual rules involved, this won't take too long. But I'm going to get started. Let's go. Okay. Simple thing that I noticed was that the red is in by itself. So that in the same box. So that means it must be at minimum 15. In addition, the red also, the minimum for red must be 15 because it's 1 plus 2 plus 3 plus 4 plus 5. The maximum of red has to be 17, right? Because there are 2 boxes in this in the 9 by 9 grid. So therefore, it must follow normal Sudoku rules. So this is at most 8 plus 9. So this is 15 to 17. Now for me, I checked what is the minimum value, right? And there was one clarification he put in, the author put in his notes that he did not put in the rules, that R4, C4 counts only once along this line. So the sum of the this gray line, well, which has to be the same, equal to the sum of all the other gray lines, is just these 4 cells, these 2, and these 2. Now, logically, what could this be? So, say this is 1 and 2, and say this is 1 and 2. This is 3 or 4, this is 3 or 4, this is 3 or 4 at least. So one of these would have to be 5 if that's the case. But that's not the minimum. That's not the minimum we want. So what is the minimum? Well, say one of these is 1, 3, right? Then that allows this to be 4, and this to be 2, and this to be 3, and then 1. So this is the minimum possible one for this gray line, which is probably the minimum then for all the other lines. Well, all the other lines have to be the same. All the other gray lines have to be the same. So this would be 4 plus 3, which is 7, plus 10, which is 17. So the gray line is at minimum 17. Now, what's the maximum? Well, the problem with these gray lines is one of the values is outside of the 9 by 9 square or grid. And because of that, it can be any value up to 45, right? This could be a value of 45, and then this is 9. So that would be actually 54 there. So that doesn't limit things on the most. This is pretty long, so it obviously doesn't limit things on the most. This, again, could be 45 to 45, so that could be 90 at most, so that doesn't help. Again, this could be 45 plus 9, plus other stuff. So we can only look at the lines that are internal to the 9 by 9 square. Now, you would think, since there are 4 unique digits, that the maximum here would be 30, right? Because it's 6 plus 7 plus 8 plus 9. But the problem is that this set of 4 shares 2 digits, or has to be in the same column as 3 of the digits here. So one of these has to be 5, at least. And then the other one would have to be 6. So then you would say that the minimum is 29, right? But if it's 29, this would only contain 4 digits from 5, 7, 8, 9. This would also contain only 4 digits from 5, 7, 8, 9. So that's not possible. So it would have to be 28, actually. So the minimum here for the gray line is 17. The maximum is 28. Therefore, value-wise, what can this be? This has to be at maximum 28. So if it is 28, what's the maximum this number could be, right? This is an x sum for both this way and this way, right? So if this were 5, the minimum for the x value of this way would be 15, and the minimum for this one would be 15. Obviously, it doesn't really work that way, because then these are essentially, well, I guess it could be. This could be 1, 2, 3, 4, 5, and then these two would be, yeah. So the minimum would be 15 and 15, which adds up to 30. So this cannot be 5 or more. It can't be 1, because then this would be 1 and 1, and that would equal 2. So it could be 2, it could be 3, it could be 4 here. In addition, oh yeah, for this set, this red line, since it can only be at most 17, that means this has to be, this must contain a 1, 2, and a 3. Let's not do it that way. I don't like doing that. It must contain a 1, 2, or 3, and it can be at most 4 and 7, right? So 1 plus 2 plus 3 is 6, plus 4 plus 7 is 17, and that's the largest it can be. So this is 1 through 7. So 1, 2, and 3 have to be on the line. So 4, 5, 6, 7, 8, and 9 can be outside the line. And we know the 8 and the 9 are outside the line in box 1. So this can't be 1. Well, actually, it could be 1. Never mind. This has to be 6 through 9, because it's 15 to 17, and so minimum would be 6, 9 for those. Okay, now what happens if we make this 17? If this is 17, this becomes 8 and 9, and this has to be 8 and 9. Therefore, 8 and 9 cannot be here, 8 and 9 cannot be here, 8 and 9 can't be here, therefore both 8 and 9 have to be here. But that's already 17, and you have an extra digit that you have to add to it, which is not possible. So 8 and 6, 17 does not work. What about 16? It's the same problem. You have 7 and 9, which eliminates 7 and 9 here. Therefore, and this can't be 7 and 9 because we got clarification on that rule. So this would be 7 and 9 plus an extra digit, which cannot be 0, and so that doesn't add up to 16 either. Therefore, we know red's value is 15. This has to be 15, which means this cannot be 6 or 7. So this is 1, 2, 3, 4, 5. This cannot be 4, 5. So 6, 7, 8, 9. This has to be one of 6, 7, 8, and 9. This has to be one of 6, 7, 8, and 9. But it cannot be the same, right? If it were the same, you run into the same problem that we ran into with 8 and 9 and 7 and 9, which is if this is the same, this is the same, then these two numbers have to be in this set of 3. But there's also an additional digit which is added together, which means that it can no longer add up to 15. So these are different from these specifically. So let's color those in. We'll make these, let's make these yellow and these orange, just so we don't have the red problem, red on red. So yellow cannot be here. Yellow has to be one of these set, right? And one of them at least has to be here. Orange cannot be here. Orange has to be in this set. And at least one of them has to be here. Can both of them be there is the question. Maybe. Then this could be 6, 7. This would be 2. Okay, so this cannot be 6, 7, 8, or 9. This has to be 1 through 5. Can it actually be 5? Yeah, maybe. It adds up to 15, and then one of them's 1. Yeah. We just know at least 2 of them are here. This becomes 15 then. This is 15. This is 15. That means these 3 must add up to 15 also. Interesting. So it could be 2, 4, 2, 4, 2, 4, 9. So this is 1 through 5. This is 1 through 5. This is 1 through 5. If this were 28, oh, an additional thing is that this couldn't be 30 anyways because this is 6, 7, 8, or 9. This is 6, 7, 8, or 9. That means it can't be 30. In addition, okay, so if it were 28, say it were 28, what are the values, what are the digits that have to be on that line? If it were 28, it's either 4, 7, 8, 9 or 5, 6, 8, 9. So then 8, 9 would be eliminated here. 8, 9 would be eliminated here. So this cannot be 6 since this would be 13 then, which doesn't fit this rule. So it cannot be 28 for gray. 27 I think works though. 27 could be 3, 7, 8, 9. Actually, it doesn't, we don't even know that. But 4, wait, maybe 27 would be 4, 5. No, it can't be 4, 5. 4, 6, 8, 9. Right? Yeah, 27 could be 4, 6, 8, 9, which would leave us 7. And then 5, 6, 7, 9. Yeah, that adds up to 27, which would leave an 8. And that would make that possible to be. So this is no longer 28, it's actually 27. So that at maximum. So it's 17 to 27. 17 minimum, 27 maximum. Even if it were 27 maximum. So say that were the case, right? So one of them's 7, one of them's 8 here, which means this is 6 and 9. So one of them would have to be 7, one of them would have to be 8. So you had 4, it's 4, 5, 6, 7, 8, and 9, right? And then this is also 4, 5, 6, 7, 8, and 9. But the rest would have to be 1 through 6. 6. So 7 and 8. 6 and 9 cannot be here. These 3 must add up to 15 also. Oh, and then, okay, so let's not do that one yet. Let's not go that route. What about these values, right? Since this is at most 27, what can this be? This also has to be at least 17. So this can never be 1. Can it be 2, 3, or 4? So say it's 6. It could be 6 and 21, and that would work. It cannot be 1, though, because then this would be 1 and 1. So this has to be at, can it be 2? If it's 2, this is at most 2 and 9. Oh yeah, but that works because it's between 17 and 27. So this is 2 through 6. This is 2 through 6. This cannot be 2 through 6. It has to be 2 through 5. Right? If you have 5 and 1, 2, so that would be 8. Yeah, 2 through 5 works. It could even be 1 actually here. This one specifically could be 1. Because if this is 1, that's 1 therefore. But then these two could add up to 15, which would work because that's 17, right? If one of these is 17, we know this is minimum 10. This is minimum 3. So you would have 17 plus 3, which is 20, plus 10, which is 30. So this can never be 7 or 17. That doesn't really help us much. What's the maximum then? It could be 27 minus 13. So it could be 14. Oh, that's an interesting interaction. We know these two values add up to whatever the gray value is. Same as these two, right? It could be 6. So say this was 6. This would be 21. Okay, let's try that. So say this was 6 and this is 6 and this is 21 and this is 21. This is 27. So this is at maximum, right, to be 6. So this can't be 6, which means that can't be 9. This can't be 6, so that can't be 9. This means this has to be 1, 2, 3, 4, 5, which means this is 7, 8, 9. I don't think that works. This would also be 1, 2, 3, 4, 5, which means this is 7, 8, 9, 7, 8, 9, 7, 8, 9. The problem is this one, right? This becomes 7, 8, 9, 7, 8, 9, 7, 8, 9. That's specifically for this one, though. This one seems okay being that way. So if this is 6, this would have to be 7, 8, 9, 7, 8, 9, 7, 8, 9. Which means this is at max 3 plus 4 plus 5 plus 6. 3 plus 4 plus 5 plus 6, right? Which means that adds up to 18. So that's not the same as 27. So this cannot be 6. We still don't know about that one. That one seems okay to be 6. Okay, so this one can't be 6. Since that can't be 6, this is only 2 through 5. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. So this has to be 6 through 9, specifically. We know this is 6 through 9. There has to be one of orange here, right? There cannot be both, because then that would form 15 plus an extra digit, which doesn't work. So one of these is 6, 7, 8, 9, but it's only one. So the other one has to be here. So there cannot be in row 7 of 6 through 9 in the other cells. Right? So one of these is 6, 7, 8, 9. The other one is not. That's actually interesting, then. So 2, 6, 7, 6, 7. This could be 8 or 9, and then that would be 8 or 9. So that's possible. So this one has to be orange. Actually, no, we don't know that the other one. So this one has to be orange. One of the oranges. This is one of the oranges. We're not given much information about the other one. So this is 2 through 5. And again, this could be 2, 15. So this could actually still be 6. We don't know. This one just can't be 7, 8, and 9. Okay, if that's the case, this would be 6. So say this was 21. We're just going to try to make this 21. So then we have 1, 2, 3, 4, 5 here. Because that plus 6 must add up to 21. We have, this can't be 6, this can't be 9. This is 7, 8, 9. So we know this is 27 then. Which means one of these is 4, 6, 8, 9. And the other one is 5, 6, 7, 9. So 4, 5, 6, 7, 8, 9. This can't be 6. So one of these is 7 or 8. One of these is 7 or 8. So then this has to be 7 or 8. This becomes 6 and 9. So this is 6. This is 9. This cannot be 9. This can't be 6. One of 7 or 8 is here. This can't be 6. Therefore, this is 6. This is also 4, 5, 6, 7, 8, 9. So there cannot be a 7, 8, or 9 here. So this is 1 through 6. This is 1 through 6. It has to be 4, 5. 4, 5, 7. No, 4, 6, 7, 9. No, 4, 6, 8, 9. And then 5, 6, 7, 9. So the 6 cannot be here either, if that's the case. So this can't be 6. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This can't be 7 or 8. Which means... Oh, interesting. One of these is 7, 8, or 9. But that seems plausible. One of these is 7 or 8. This still can be both 6 and 9. One of 7 or 8's here. I mean, this seems plausible. It's 17, so you have 10 degrees of freedom. It's 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6, 9. One of these has to be 6 or 9. This can no longer be 2, right? Because if it's 27, 2, it would have to be 2 and 27. Right, sorry, 2 and 24. And 2 digits cannot add up to 24. 3, sorry, it'd be 2 and 25. And 2 digits can add up to 25. 3 doesn't work either, right? Because if this is 3, this would have to be 24. But then you would have to have 3 plus 8 plus 9 is the most. So 3 doesn't work. This would have to be 4 or 5. So then this would be 22 or 23. 22 or 23, right? 22 with 5 or 23 with 4. I don't think that works. Okay. Right. That doesn't work. If this is 22, so which is the minimum this could be, this would be 5. these 4 digits... Actually, maybe that does work. If this is 5 and 22... that means 22 equals these 5 digits, which means this is 17. Yeah, that actually seems to work okay. This would be 17. This is 3 at minimum. This is 3 at minimum, so you still have a decent amount of degrees of freedom. If this was 23, though, I don't think that works, right? If this is 23 and 4, that means these 3 digits add up to 19. These 3 digits add up to 6, because it's 1 plus 2 plus 3. 19 plus 6 is 25, plus 3 is 28, so that's not possible. So therefore, this would have to be 5. This would have to be 22. So the 5 cannot be here, which means the 5 is here. So this can't be 5 at all. This can't be 5. So one of these is 5. So this can't be 5. We know this adds up to 17. Because this is 22 and 5. This is 21 and 6. So these can't be 5. This adds up to... So we know, again, this is 5. This is 17 here. So this is 22. The rest of this adds up to 23. So this is at most 3 plus 4. 3 plus 4 plus 8 plus 9. And I think that does work, right? So these 5 digits add up to 22. These 4 digits add up to 23. If this is 9, say this was 7 and 8, right? If this is 7, 8, 7, 8, that's 15, plus 3 plus 4, that's 22. So that does not work. So this one would have to be a 9. So this could be 8, which would be 17, plus 3 plus 4, which would be 24. And so it would be 8 with 2 or 4, or 7 with 3 or 4. Okay, so this would be 8 with 2 or 4, or 7 with 3 or 4. So then this could not be 4. Therefore, this could be 4. Sorry, this one has to be 4, which means this cannot be 4 or 5. This has to be 5 plus 6 plus 7 plus 9. So it's 18. No. 5 plus 6 plus 8 plus 9. Wait. Wait, can it be 27 even? I think I might have miscalculated that. If it's 27, it's either 3 plus 7 plus 8 plus 9, which doesn't give us anything. 4 plus 6 plus 8 plus 9. So that doesn't work either. Okay, it cannot be then 27. I miscalculated essentially, right? Because it cannot be 27. I tried making it 27, but I think I messed up there. If this is 27, you can only have 3 plus 7 plus 8 plus 9. You could have 4 plus 6 plus 8 plus 9. right? 4 plus 6, which is 10, plus 8 plus 9 is 27, right? Can you actually have any 5 with that? It would have to be... Oh no, 5 plus 6 plus 7 plus 9 works. Okay. Sorry, I don't know why I was completely messing that up. Okay, 5 plus 6 plus 7, which is 18, plus 9 is 27. Right, so that works. Okay, so let's go back to this testing again. We know that this is 5, 2, this has to be 9. This has to be 5 plus 6 plus 7 plus 9, because the 4 is here. So this is 5 plus 6 plus 7 plus 9. This has to be... Okay, so then this has to be 8. So this is 17. This is 22. So these two must add up to 23. So therefore this is 2 and 4. This can't be 2 and 4. We have 1, 3, 5, not 5. 1, 3, 6, 7. This is 1, 3, 6, 7. So this can't be 6. We have 2 and 4. This has to be 7, which means this is 4, 6, 8, and 9. So no 7 here. No 5 or 7. No 4 here. So this is 7, 1, 2, 3, 5, 1, 2, 3, 5. This would be 2 and 4. So this is 4. This is 4. This can't be 7. So the 4 cannot be anywhere here. This can't be 4 either, because it can't be anywhere here. This might just actually be solving the correct value, but yeah. So this can't be 7. We have... This can't be 5 or 6. This can't be 5. So the 5 has to be here. This must contain a 7. But we don't know anything else about that. So this is 6, which means this can't be 6, which means this has to be 6. So this would add up to 17. This is 21 there still, so this is 6. This is 5, 6, 7, 9. So the 7 is here, which means the 7 cannot be here, which means this is 7. I don't know. Oh, I put 6 instead of 5. So I put 6 in instead of removing the 5. Okay, so can this ever be 7? I don't think so, right? This would be 17 plus 7, and then this is at least 6. So this is at least 6. We know this is 17. So this is at least 6. Okay, so this is 1 and 3. So this cannot be 1 and 3 here. This is 17. This is 1, 2, and 3 at least. So this is 17. If this is 17, this is 6, that's 23, so this is 4 at most, so this is 2 or 4. This is 17. We know this is at least 6. So 17 plus 6 means this is 1 and 3 at most, right? So this is 2. This can't be 2. The 5 has to be one of those two. If this is 5, does that work? 5 and 2 makes 7. Plus 17. That's 24. This could be 1 and 2. So that would work. This is always 1, so this can't be 1. This would have to be 3 then. So this is always 1 and 2, so this can't be 2. This can't be 3 or 1. This is 1 or 7. Yeah, this might be solving it. This is 2. This is 17, right? So this is 17, 19, 22. This has to be 5. This would be 5. This would be 4. This cannot be 2 anymore. So this is 1 and 2, which means this can't be 1 or 2. So this could be 3, 4, no 5, no 6, 8, or 9. So this can't be 9 specifically. 9 is one of those 3. This is 3 through 9, but no 6, obviously. This one can't be 7. This one can't be 7 because the 7 has to be one of these. This can't be 9. So this becomes 178, but this can't be 1 specifically, so the 1 is one of those two. This can't be 5, so the 5 is here. Yeah, this actually might just be solving it. But we have to figure out why the gray doesn't work, if that's the case. I don't know, we'll see. So this is... two or three. The 4 cannot be here, right? The 4 has to be one of those 3. One of these is 2. The 3 also has to be there. So this is 2, 3. This becomes 4, 6, 8, and 9. This can't be 6 because the 6 has to be here. So this is 4, 8, or 9. This cannot be 6 or 7 here. So this is 1, 2, 3, 4, 5, 8, or 9. So far, this seems kosher. Okay. This is 6, so this cannot be 6. This has to be 6, so this can't be the 6. Therefore, this is 6. 4, 8, 9. So this all seems kosher. This is 6, so this can't be 6. One of these 4 is 6. We don't know which. Yeah, seems fine. So again, this is 27. If this is 27, I think this has to be 3 then, right? Also, we have 1 here and we have 1 here. So 1 can never be in any of these squares then because of that. Right, because where is the 1 in column 9? It would have to be here. So 1 would have to be here. This adds up to 15 without a 1. So it could be 2, 4, 9. Can this ever be 2? If this is 2, this can be with 2, 9, and then 2, 8. Which would mean this is 11 and 10, which would add up to only 21. So this could not be 2 if this is 27. If the gray line is 27. So this has to be 3 then. Which means 3 is out everywhere here. This is 3, which means these two add up to 12. So this cannot be 1. This cannot be 2. So this can't be 2. It could be 4, 8, or 5, 7. Right? So this is 4, 8, or 5, 7. So this has to be 2 or 5. Or 2 or 4. Or 4 or 5, technically. No, it can't be because of that. This is 3 with 12. It's only 4, 8, or 5, 7 anymore. So with this has to be the other orange, which means this is 1, this is 2, this is 4. This all seems to actually work fine. So 1 can be with 5 and 9, or 6 and 8. So if this 5, so this is 6 or 9, this is 6 or 9. So this is either 6, 4, 5, which is not possible, or 9, 2, 4. So this would be 2 and 4, which would make that 5. This is 7. This would have to be 6 and 8. So this would be 6. This cannot be 8. It cannot be 4, so this is 9. This would be 4, 6, and 8. So this is 9. This is 5. This is 7. This all seems fine. This is 7. So this would have to be a 1, 8 pair, which means this is 9. This is 8. This is 7. This all seems kosher. We might just be solving it, but then we have to prove that it has to be 27, which is... That seems a little difficult, to be honest. This can't be 7, therefore this is the 7. This is the only possible 7. 4, 8, 3, 4, 8. So this is 9. This has to be 8 then. This is 7. This can't be 2 or 4. This can't be 2 or 4. No 1s here. No 8 or 9s allowed here. This can't be 3. This can't be 3. It can't be 5. Can't be 8. So 3 is one of those. So this is 21. So this adds up fine. This is 4. Huh. I'm not sure how... Yeah, this is looking like this actual solution. So this is a 2, 6 pair. The 4 has to be here because this can't be 4 and this can't be 4. So this is 4 with 1, 3, or 5. No 1 here, no 3 or 5 here. This becomes 1, 2, 4, 9. So this is 6. This is 8. This is 6. This is 2. This can't be 2 here. Yeah, this looks like an actual solution. If this is 4, say this was 4, this would have to be, I don't know, 4 plus 9 plus 2 plus 7. Does that even work? I don't think so, right? So if this is 4, this would be 1, this would be 2 and 9. So 4 plus 2 plus 9 plus 7 would be the first 4 digits. 4 plus 2 plus 9 is 15, plus 7 is 22. So this would be 22 and 4, which is not possible then because the 1 is here. And this is at least 3, 4, 5. So this cannot be 4. It cannot be 1 if it's 27, so this would have to be 2. Which means this could not be 2. So this would be 1, 3, and 4. This would be 2 and 5. So this could not be 2. This could not be 2. If it's 1 or 4, that means this would be 6. So that would be at most 6 plus 2 plus 4 plus 5. So that would be 8 plus 4, 12, plus 5, which is 17. So that would not fulfill it. So this could not be 1 or 4, therefore this would have to be the 9. So this can't be 9. This is 11, so this adds up to 11. This is 11, so 11 plus 11 is 22, so this would have to be 5. Again, this looks like it all works. So, This would have to be 2 then. This is 5. This x sum would be 8, 9, or 10. This becomes 3. This is 1. This is 2. Which is 7. This is 1. This has to be 7 then. This is 6, 8, 6, 8, which means this is 4. This is 4. This is 3. This is 1. This is 4. It can't be 1. This is 8. This is 1. This is 8. Yeah, this actually looks like the solve. So we actually need to work backwards and figure out why it has to be 27 then. Because this looks like it actually works. Oh boy. Okay, this is 9. Yeah, this looks like it just actually works. Because this is all adding up right now, and that seems to work pretty well. So this is 8 or 10. That means this must be at least 11. right? This is 8 or 10. If 10 at most, this is 14. This would have to be oh, it has to be 13 at least. So this cannot be 1. Yeah, this looks like the solution. So we need to figure out why the gray cannot. Okay, so... Oh, wait. 3. We have the solution here then. This is 11. This is... Right? This is 11 and this is 16, so that works. This all looks like it works. Oh, no. No. Okay, so now we have to disprove the 27. This all looks like it works. Let's just try to kosher everything, but I think this one actually works. I was going down this trying to disprove 27, but then this tells me that this is looking like it is 27, right? So this is 8 or 10. This has to be at least 13. So it's at least 3. Okay, so this is counted twice. Wait, so if this is 4, and this is 13, and this is 10, that works. So then this would be 3, 8, 7. 3, 8, and 7, that's 18. So that would not specifically work. But what if this is 1? If this is 1, this would be 3. This could be 3 still. It could be 4 even. Yeah, this all looks like it works. I need to now disprove everything below 27. That's going to be difficult, I think. Right? Okay. We're just going back. Because we solved it, essentially, it seems, but we have to now disprove what we solved. Because I was trying to, again, okay, so I was kind of essentially trying to use a scientific method. And that's what a lot of these variant Sudokus I tend to solve. That's the way I tend to solve it, is showing that something cannot be the case. And therefore, that eliminates possibilities. But the possibility I went down, it seems to actually work. So, unfortunately, we gotta disprove 26 and below now. Oh, that's gonna be difficult, I think. And then we also have to disprove that that 6 can't be there. Okay, so... Huh. Ooh, that's... Okay, so 17, I think it should be fairly easy to disprove. Right? If it's 17, we know this is 1, 2, 3, 4. One of these is 1, 2, or 3. The other one is 1, 2, or 3. Therefore, this would have to be 5. But, okay, so that's disproven already immediately. Because this is 5, which means this would have to be 15. And therefore, this would be 15 plus 5, which would be 20. So that's already disproven. So 17 is ruled out. What about 18? Okay, let's try 18. 18 means, okay, this is at minimum 10. This is at minimum 3. How many degrees of freedom do we have? This is at minimum 10, right? So this is at minimum 10. So this is 1, 2, 3, 4 at minimum. Or this is 1, 2, 3, 4 at minimum. What's the minimum for these 7 cells? This one would have to be here. That seems okay. This is 10 plus 16, so this is 1 or 2. Oh, that's actually very interesting. If this was 5. Okay, so... Oh, maybe that's the way to approach it. If this is 5, that means this is minimum 20. So say that means this is 5, right? This is at minimum 20. So this is the minimum we have. So this is 10. So this has to be at minimum 20. But if this is not 5, that means this is 5. Oh, okay. That's okay, okay. That helps a lot. That helps a lot. One of these is 1 through 5, right? Oh, wait, no, the 5 could be here. Okay, so one of these would have to be 3 or 4. The other one also would have to be 3 or 4 at least. Or 2, 3, or 4. So if this is 5, then you have a minimum 20. But say this is not 5. Say this is like 2 or something. If this is 2, I don't think that works then, right? Because this is 16. Say this was 16. Then 2, it can't be 16. Oh, okay. So 2 is ruled out. Yes, this can never be 2. I think previously... No, it wasn't. Yeah. This could never be 2. This can never be 2 either. Because it's only 2 in whatever that number is. And if this is 2, this would be 16, essentially, if it were 18. So this 2 and 18, or this would be 16, right? 2 and 16 means these two numbers would have to add up to 16, which is not possible with just 2 and a digit. So this can never be 2. This can never be 2. This still could be 1, right? Because it could be 1, 1, and then this adds up to 16 in that instance. So that seems kosher. So this is 3, 4, 5. If this is 3, this has to be 15 at least. So we know if this is 5, then this is at minimum 20. Because this is 15, right? So if this is 5, this is at minimum 15. So this is at least 20. So that can't be 18 or 19. Now we have to test 3 and 4 here, right? If this were 3, this would be 15 at least. So this would be, or it has to be 50, yeah, 15 at least. So that means these two digits would add up to 12. If that's the case, right? Because you have 15 minus 3 is 12. So this adds up to 12. So this would be either 4, 8 or 3, 5, 7. 4, 8 or 5, 7. So this is 12, we know. So this could never be 6. It could never be 5. It would also have to be 3 or 4. So this would have, okay, so this 3 means that's not a 3, so this would have to be 3. This would have to be a 4. Which would mean this would be 14, right? Which would mean this is equal to 10. So this is 10. This is 10. This is 12. I'm starting to see something. This is 10. This is 12. Okay. I see how you disprove it. I'm starting to see it, I think. Because this is 3 and 4, right? Because this is 3, that forces this not to be 3, which means that has to be 3. So this cannot be and 3 itself. So this would have to be 4. Because of that, this is 15, this is 14, right? And the problem is, as it gets bigger and bigger, these two sets have to be bigger and bigger. So if this is 15, so okay, say we had any number from, so say this is x, right? We're just going to put a 0 there. Say this is x, right? And this is an x. First of all, we know, okay, we know because of the minimum value is 18, this can never be 2, right? Because if this is 2, this would have to be 16, but then you would have to have 2 digits add up to 16, which is impossible. So this has to be 3 through 6. But say this was one of 3, 4, 5, right? If this is one of 3, 4, 5, that means it cannot be here. It has to be here. So this has to be a different number from 3, 4, or 5. And because of that, if this adds up to 50, so say this is, okay, say this one of these is 5 and one of these is 4. That means, at minimum, if this is 5, no, actually, I think that works. Not works, but that's not as, okay, just say one of these is 3. If one of these is 3, that means these 2 digits have to add up to 18 minus 3, right? Because these 3 digits would add up to whatever this is, right? Or not 18, 15 minus 3. Okay, yeah, let's just go through. Let's go through an example. So say this was 3 and this was, the gray was 18. This would have to be 15. This can no longer be 3. Can't be 6, obviously. Can't be 5. So this would have to be 4. So this would be 14, right? So the first 4 digits then have to add up to 14, which means these add up to 10. So these add up to 10 and these add up to 12. That's already 22. And we said that the gray value was 18. So we've shown that if you have a 3, if you have a 5, you can't, it doesn't work, right? So for 18 and 19, it has to be some combination of 3 and 4 somewhere. And we've shown for 18 it doesn't work. For 19, it's even worse, right? Because this becomes 16 and this becomes 15. And therefore, the first 4 digits have to add up to 15. So these 3 digits add up to 11. These 3 digits must add up to 16. So this actually has to add up to 13. So we have 13 here, and this is 11. That's 24. So that's the problem with that, with 3 and 4 specifically. So you cannot have 3 and 4 because it just keeps getting bigger and bigger, right? So again, we tried 15. We tried 15 here and 14 here. These 3 digits are 10. These 2 digits are 12. So that's 22 already. And let's try it with even the largest one, right? Oh, well, okay. If we, no, so okay, this is 22 then, if that's the case. So 22 versus 18 for these 5 numbers. Now say this was 16 and this was 15, right? Because this would be 19. If that's the case, these 3 digits add up to 11. These 2 digits add up to 13. That's 24 versus 19. So it's just getting bigger and bigger, right? And I'm guessing that this would be 26 then, if this because it increases. So this would be 17, and this would be 16. These three digits must add up to 12. These two digits must add up to 14. That's 26, yes. So every time the grade number and value goes up for 3 and 4, it just keeps getting higher and higher. So we know now this can never have a 3 and a 4 together. And you can never have the same values here, right? If it's 3 through 5. And we know one of these is 3, 4, 5. So because of that, we know 3 and 4 does not work. So 3 is right out. It could potentially be 4 and 5. So let's try 4 and 5. If we try 4 and 5, so say this one was 4 and this one was 5. Again, it cannot have two values that are the same here because that eliminates here. So if this is 4, that eliminates the 4s here, which means that has to be 4. And so that can't be 4. If this is 5 here, that eliminates 5 here, which means that has to be 5. That can't be 5, right? So we know specifically it can never be the same digits. So this has to be either 3, 4, 3, 5. 3, 5 doesn't work. Obviously, for the same issues. Right. 3 and 5 actually might be... Actually, what about 3 and 6? We didn't think about that. What if it's 3 and 6? If it's 3 and 6, well, first of all, this has to be 21 then. So it's 27 no matter what then. So, yeah. Okay, that shows then that would have to be 27, which is what we're trying to prove. So, we're trying to do it without this being 6. And if that's 6, then this has to be 21 because that's the minimum for these 6 digits. So this would be 21 and 6, which would mean this is 27. So without this being 6, 3 doesn't work because we didn't try 3 and 5, I guess. We didn't really try. So this, again, so this is 3. Let's try the minimum, which would be 18. So this would be 15. This would be 13, which is not possible. So with a 5, it has to be 20 at least, right? So we've shown that 3 and 5 doesn't work. So 3 and 4 doesn't work, 3 and 5 doesn't, or 3 and 5 could work with 20 and above. We'll have to try that later. Actually, maybe we just try it now, so we can eliminate 3 altogether. So say 3 and 5, and let's say it's 20, right? So this is 15. This would be 17? Is that right? It adds up to 20. Yeah, 3 plus 17 is 20. Therefore, these two digits add up to 14. These 4 digits add up to 10, but that's 24, which is already bigger than 20. And I think that gets worse and worse again. So say this was 20, say the grade line added 21. This is 16. This is, oh, wait, no, that would be 17. This would be 18, right? And then this is fine. So this is 15, and these 4 would add up to 11. So that's 26. And the previous one was 24. So again, the gray line total would increase by 1, but these 6 sum together keeps adding up by 2 for that could be the scenario. So 3 and 5 does not work. Now we have to test 4 and 5, right? Because 5 and 5 just doesn't work because then it eliminates all possibilities here. So let's try 4 and 5. So we know 3 doesn't work. So 3 does not work with 4, 5. It could work with 6, but if it's a 6, then it always has to be 27 for the gray line. So if it's 4 and this is 5, so that means it has to be 20 at minimum. Okay, so we know then this is at least 20. Let's make that 20. So this is at least 20 now because it has to be 5. So say then this is 15. This would have to be 16. So this is 12, and this is 10. So that's 22 for these 6 numbers, and 20 for the total, which is an impossibility. So that doesn't work for 20. And I think it has the same scenario if you have 21 and you keep going up, right? 17, this becomes 13, this becomes 11. That's 24 versus the value of 21. So the total of these 6 cells goes up by 2, whereas a total of the gray cells goes up by 1 only. So it'll never reach each other. Therefore, we have shown 3, 4, 3, 5, and 3 and 4, 5 do not work. Therefore, we know this value is a 6. So this has to be 6 then. We know this is 6 then, and this therefore the first 6 digits always add up to 21 because it's 1 plus 2 plus 3 plus 4 plus 5. So this has to be 1, 2, 3, 4, 5. So we've now shown this is 21. 21. This has to be a value of 27, which means this cannot be 6. This is 7, 8, or 9. This is 21. If this was 3 and this is 24, it would be 3 plus 8 plus 9, but that's at, so this cannot be 3. So this is 4, 5. So this is 22 and 20 or 23. Like we're going down that path. So this is 22 or 23. This is 6. This is 21. This has to be 7, 8, or 9. So this cannot be 9 because this can't be 6. This is 7, 8, or 9. This is 6. This is 27. So the first 4. Okay, so now we have to disprove these. So it's 27. So this cannot be 1 anymore because this is at most 1 plus 1. Therefore, these two values would have to be at least... So this is 27. We know this is 27. So therefore, this has to be what the scenario it had to be 4, 6, 8, 9 or 5, 6, 7, 9. So this is 4, 6, 8, 9, 8, 9 or 5, 6, 7, 9. So this becomes a 7, 8, 7, 8 pair, which means this cannot be 7, 8 or 7, 8. So this is 6, this is 9. This can't be 9. Okay, so then we're essentially we're proving it again, right? One of these is 7 or 8. The other one has to be 7 or 8 here, right? Right. So this is 7 or 8, which means none of these can be 7 or 8. And the 6 always is here then. So this can't be 6. So therefore this has to be 6. And again, this is 4, 6, 8, 9. But this can't be 6. Or 5, 6, 7, 9, right? So 7 and 8 with 6. So these have to be 1 through 5. These have to be 1 through 5. Right? Because 6, 7, 8, and 9 are accounted for specifically with this line and this cell. Same here. So this is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5. This becomes not 6, so 6 has to be here. 6 has to be here. And we're just basically going down the path again to proving things. So this is 22 or 23. How do we show this is 4, not 4? That's really the question. Well, maybe just assume it's 4, right? Okay, assume this is 4. If this is 4, this would have to be 23. So these 4 digits would add up to 23. Because these 4 digits add up to 23, these 3 would have to add up to 19. 19 and these 3 digits, this is 6 at least. So 19 plus 6 is 25. And this would have to be 3 at least. So that would be 28 for this whole line, which means 4 is not possible. Therefore, we know this is 5 and this is 22. So this is 22, this is 5, this can't be 5. The 5 is here, so there cannot be a 5 here. We tried, 5, 6, 7, 8, 9. So this can't be 5 anymore. This is 4, 7. This has to be 5 here. This can't be 5. So this is 1, 2, 3, 4. This 5 means that these 5 digits add up to 22. So this is 17. This is at least 6. So we have 17 plus 6, which is 23. So this is at most 4. We know that these are 22. This has to be 23. And we tried, again, earlier, this was 7 and 8. Even if this is 7, 8, 7, 8, and 3, 4, that doesn't work, right? That's 15 plus 3, 4, which is 22, but it has to add up to 23. Therefore, this cannot be 7 or 8. Therefore, this must be the 9. So we know this is 9. This must have the other 7 or 8. Right. And so say this was 9 and 7. What digit has to be here specifically? Or what value? If it's 9 and 7, we know this is 22. So this is 23. 23 minus 9 minus 8. Let's just do minus 8. So the most it could be. So 24 minus 9 minus 8, which is 17, would mean this is... Sorry, 23 minus 9 minus 8. So that's minus 17. Means this has to be 6. And since it cannot be 5, and the 6, 7, 8, 9 are already taken into account, that means this has to be at least 2 and 4. And it could be 3 and 4. But the 4 always has to be here, which eliminates 4 from the rest of box 6. No, it's the other way around. It eliminates all the box. So therefore, this can no longer be 4, 6, 8, 9. It has to be 5, 6, 7, 9. Which means this can't be 7. This is 8. This is 7, which eliminates this from being 5, 6, 7, 9, and it has to be 4, 6, 8, 9. So no 7 and no 5, which means the 4 is in one of these 4 cells. So this cannot be 4 in box 3. The 5 cannot be here in box 6. This can't be 7 because of this. So this is 1, 2, 3, 4, 5. The 7, 8. So, and we're just basically solving this again. So this is always 4, and it's 1, 2, or 3. So this cannot be 4. This can't be 7. This can't be 7. So the 7 has to be one of those two, and it could be 1, 2, 3, 4, 5, 8, and 9. This can't be 9, though, specifically. So we know this is 8 and 9. Actually, then this forces this to be 2 and 4. Right? Because we know this is 23 exactly. So this is 2 and 4. This has to be 1 and 3, which means this can't be 1 or 3. This can't be 2. This becomes a 1, 3, 6, and 7. This is 1, 3, 6, and 7. This can't be 6. But this can't be 6, therefore this has to have a 6. Therefore this can't be 6 in box 4, because the 6 is already accounted for. Therefore, in row 4, where is the 6? This is the only cell that can have the 6, so this is 6. So we know, again, this is 17. This now has to be at least 6. So this means this is 17 plus 6, which is 23. So this is at most 4. So this has to have a 1, and it's either with a 2 or a 3. So this cannot be 1. This cannot be 1. This can't be 1 anymore. So this is a 3, which makes this 1, 2. So we know this adds up to 3. This is 1 and 7, so this cannot be 7. Therefore, the 7's over here. This can't be 3. This can't be 2 here. So this is 4 and 5, which means this can't be 4 in box 5 because we already have a 4, 5 pair. So that's 2. This is still adds up to 17. This adds up to 3, which is 20. This must add up to 7. So this has to be the 5, and this has to be the 4, which means this cannot be 5. So now we have 1, 7, and 8. So this can't be 1. This is 7 or 8. This is 1, 7, or 8. This can't be 2. Let's remove the coloring, because the colorings are distracting now. Okay. So 7 or 8 can be one of those three. This is 1 or 2 again, so these can't be 2. So we have this adding up to 27, so that works fine. This is 21. This is good. This has to be 6, so this cannot be 6, so therefore this has to be the 6. 4 has to be here in one of those two. 2 has to be here in one of those two. 3 also has to be here because that's 3, this is 3, and this is 3. So this is 4, 8, and 9. So yeah, we're just solving this again, but you know, hey, you know, makes sense. This can't be 1 because if this is 1, this is 1 and 1. So 27 minus 2 would be 25, and 2 digits cannot equal 25, cannot sum to 25. If this was 2, this would be at most 11. So it would be 11 plus 2 plus 9. So we know the 1 is here, so this can't be 1. What about 2? This is 5, so neither of these can be 5. One of these 3 is 5. Okay. This is 1, 2, 3, 4, 5, 6, and 9. Oh yeah, this must add up to 27. Hmm. So this is 3, 4, 5, 7, 8, 9. This can't be 7. This is a 7, so this can't be 7. This can't be 9, obviously. So the 2 has to be here. This is 1, 2, 3, 4, 5, 6. This can't be 2 or 6, so this could be 2. This has to be 6 here. Okay, so this has to be 6. This has to be 5 also. Where is the 1? The 1 is here. The 1 is here. Also, the 3 is here, and the 3 is here. So all the 3s are all the 1 and 3s are accounted for in columns 7 and 8. Therefore, let's just delete this. This is 1 through 5. It cannot be 1 or 3 here, though. This cannot have 1 or 3. It could be 2, 4, 5, 6, 7, 8, 9. This can't be 6 or 9. This can't be 7 or 8 here. This could be 1 or 3. In fact, this has to be 1 or 3, right? If this is not 1 or 3, that would mean this. So these add up to 15. These 3 add up to 15. If this is not 1 or 3, this has to be 1, and this has to be 3. But there's no other digit that can add up with 1 and 3 to add up to 15. So this one has to be 1 or 3. One of these is 1, and one of these is 3. So 7 and 8. We know one of these is 7 or 8. We don't know where the other one is. Oh, wait, no. The other one has to be here. Right? So this is 1 or 3 with 7 or 8. So because of that, I don't think you can ever have a 9 with it, right? Yeah, because it adds up to 15. 7 plus 9 is 16. 8 plus 9 is 17. So 9 can never be here, which means 9 is always here, so this cannot be 9. So the 9 is one of these 3, the 9 is one of these 4. So if it's 1, it has to be 6 and 8. So if it's 1, it has to be 6 and 8 here, which seems fine. If this is 3, it's with 7 or 8, so it's either 5, 7, or 4, 8, right? So this is 1 or 3. This is one of these is 1 or 3. Okay. Say this is... So if this was 3, 4, 8, this would have to be 2. So this would be 2 with 3. So that would be 5. But then this would have to be 22. That adds up with 2 and something, which is not possible. So this can never be 3, 4, 8. So this is either 1, 6, 8 or 3, 5, 7. Okay. This is 4 and this is 4. So we have the 2 4s for column 8 and 9. So none of these can be right. I forgot about this one. This can't be 4, this can't be 4. So this is either 2 or it's 3. If this is 2, this is 5 at most, and this would be 22. So this always has to be 3. So this is 3. This can't be 3, therefore this is a 1. We got a 3 in the corner. This is 1, and therefore it has to be 1, 6, 8. So this cannot be 8. This can't be 1 or 3. This can't be 4 anymore. Well, we know that can't be 4. This is 3. It cannot be with 2. So for column 9, where is the 2? It has to be here because that's the only other place now. So this is 2. This is 4. This cannot be 4. So we have 5, 7, 8. So it's either 3, 5, 7, but that's not. So this cannot be 5. So this is 3, 7 with something. And therefore it's either 3. It has to add up to 15. So these two digits have to add up to 12, which means it's 4, 8 or 5, 7. So this can no longer be 3. This can't be 1. This can't be 3. So this is 6 and 8. So this cannot be 8 anymore. So this is 9. This can't be 6 or 9. This can't be 9. So it's 4, 6, 8, which means this can't be 8. So this is 7. This is 5. This can't be 5 or 7. This has to be the 2 then, which makes this 4 and 9. Because 6 and 8 are accounted for, which forces this to be 6. This can't be 5. This can't be 2. This can't be 7 anymore, so this is 9. This is 5. This is 7. So this becomes a 1-8 pair, which forces this not to be 8, so that's a 7. This can't be 9. This becomes a 4-8 pair, which forces this not to be 8. So that's 9. This is 8 because of these two, and this is 7 because the 7 has to be there. So no 2, 4 here. No 2, 4 here. So we know this is a 2, 6 pair because 2 and 6 cannot be anywhere else. Where 7, the 7 got eliminated here. Therefore, 7 can only be here in row 1. So that's 7. This is 8. This is 7. This is 6. This is 8. These add up. So 3, this must be 11. So we have 11. So this must be 16, which is 3, 5, and 8. That adds up to 16. So that works too. So this is 16. This has to be a 2, 6 pair again because there's no other place. And this can't be 6 anymore. So this is 2. This is 6. This cannot be 5. We know there's a 9 here. So if, and this is 1, 2, or 4, right? If this is 4, these 4 digits would then add up to 9 plus 7 plus 4 plus 2. So 2 plus 4 plus 9, which is 15, plus 7, which is 22. So this would be 22 plus 4, which is already 26, which means these two digits cannot add up to 1. So this cannot be 4, which means this is a 2. So this can't be 2. This can't be 2. So this becomes a 1, 3, 4 set. This has to be 2 and 5 because 1, 3, and 4 are here. That's a triplet, so that eliminates 1, 3, 4 in the rest of the box. So this can't be 2 or 5. This is 1 or 3. This is 1 or 3. This has to be 5. Okay. Now, what is this? This is 2, so say this was 2 and either 1 or 4. If this is 2 and 4, which is the most, this would be 6. So you would have 6 plus 2 plus 4, which is 12. But then 27 minus 12 is 15, and that cannot equal a digit. So this cannot be 1 or 4. This has to be the 9, which means this can't be 9. So this is 11. So we have this is 11. And this is 11. So we have 11 plus 11, which is 22, minus 27 is 5. So this has to be a 5, which means this can't be 5. This can't be 5. This is 1, 3, or 4. Can't be 1 because of this, so this is 3 or 4. This can't be 9 anymore. This can't be 5, so this is a 2. This is the 5, which means that's 3, 2. This is 1, 4, 3, 1, 4, 8, 1. This is 7. This is 1. This can't be the 7 anymore, so this has to be the 7 in row 2. No 4 and 8. No 1. This has to be 8 now. This is 9, 4. This is all because of Sudoku. So this can't be 7. This can't be 9. Where is the 9 in box 2? It can only be here. So that's 9. This is 2. Okay. So now we just have to logic this through. Right. And we got back to the place where we were trying to disprove this and actually started proving it. So this is 1, 3, and 4. If this is 1, this would also have to be 1. And this would be at most 4 and 1, which would mean this has to be 22, which is not possible. So this cannot be 1. Say this was 6. If this is 6, let's try 4 at most. So if this is 6, okay, let's try both of them, I guess. Say this was 6. If this is 6, this would have, and we tried this being 3. This would be 3, 6, and 7. So that would be 16. There should be 16. Oh, that works. Wait, no, that doesn't work. This would be 16. This would be 8. And this wouldn't add up, right? 16 plus 8 would be 24. This would have to be 3, but we already have a 3 in box 1. So 3, 6 does not work. What about 4, 6? If this is 6 and this is 4, then this is at least 18. This is 8. So that could work. So 4 and 6 could work. What about 8? If we have 8 and this is 3, this adds up to 18. So this is 18 and this is 10. So that's already 28. So that doesn't work. And therefore also 4 and 8 doesn't work because that just adds more value. This is 10. This would have to be at least 20, and that would be 30, right? So that doesn't work. So we know now this has to be 6, and we tried it with 3, and it doesn't work, I think, right? 3 means this is 3, 6, and 7, so this is 16, and this is 8. So 16 plus 8. Oh, we didn't try it, I don't think. If this is 3, this is 16. So this is 16, this is 8. Oh yeah, no, that's right. 16 plus 8 is 24. This would have to be 3, so that's not possible. So this is 4. This is 8. This can't be 4. This can't be 4. This now becomes 8. And this is at least, so this is 4 plus 6 plus 7. So this is 17. This is 18 or 19. So this is 18 or 19. Let's just, I guess, make this lower value. So this is 8. This is 18 or 19. If it's 19, that's already 27. So this has to be 18, which means we have 8, 18. This has to be 1. So this is 1 to add up to 27. This is 3. This is 4, 8, 4, 8. This has to be 3. We know this is 1 now because this must add up to 18. So this is 1, this is 2, this is 5, and we're just doing regular Sudoku here now by eliminating. This is 2, 5, 1, 3, 3, 5, 4, 8, 3, 8, 4, and that's a 6. And that's the solve. Took quite a while, I guess. I guess it doesn't have well, it'd be hard to have checking. But that looks like the solution. I think I solved everything on the grid. Yeah, that's the solution. Interesting, very interesting. Still took a long time. I don't know if I would consider it very hard, actually, though. Once you know that the rules are set, it just takes time, right? You just have to calculate, can't cancel things out. Plus, if you don't go down the path of trying to disprove the actual solution, then maybe you would have figured it out this little tidbit earlier, which was pretty clever, actually. I like this. I like this forcing of the possibilities down a certain path. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.